Imagine this. For months, Voyager 1, a spacecraft older than the Internet itself, had gone completely silent. 15 billion miles from Earth. No signal, no data, just silence. A silence so deep, so absolute, it felt like the universe itself had drawn a curtain. Scientists feared the worst. Had our furthest explorer finally died in the dark? Imagine this. For months, Voyager 1, a spacecraft older than the Internet itself, went completely silent. It drifted more than 15 billion miles away from Earth, farther than any human creation had ever gone. No signal, no data, just silence. A silence so vast and absolute it felt as though the universe itself had drawn a curtain. For scientists, it was unsettling. Had our most distant explorer finally succumbed to the endless dark? Was this the moment it slipped away forever, becoming nothing more than an invisible relic lost in interstellar space? And then, just as hope was fading, the spacecraft whispered back. The signal wasn't routine. It wasn't just a reboot or a simple systems check. What Voyager 1 sent back cracked open one of humanity's most deeply held illusions, the idea that beyond the sun's reach lies nothing but an empty void. Because what Voyager revealed wasn't emptiness. It was structure. It was motion. It was boundaries. Space itself was alive with activity. The spacecraft had reached the other side of the sun's protective bubble, and what it found there was stranger than anyone expected. When Voyager 1 crossed the helipause in 2012, it became the first human-made object to leave the heliosphere, the vast bubble carved by solar winds. Many assumed it would drift silently into a dark stillness. But space beyond the helipause has proven anything but quiet. In April 2024, after months of scrambled transmissions, Voyager came back online, and the data it began sending shook the very foundation of astrophysics. Out there, beyond the shield of our sun, space is humming. A low, steady oscillation fills the void like the pulse of some hidden organism. Voyager's plasma wave instrument detected a kind of ambient energy, a cosmic hum whispering through the interstellar medium. But this wasn't just background noise. Alongside the hum were density spikes, sudden bursts of pressure, almost like shock waves frozen in space. Many of these disturbances are thought to be remnants of ancient supernova explosions, the echoes of stellar deaths that happened thousands, even millions of years ago. It is as though Voyager is sailing across an ocean of memory. The interstellar medium is not an empty corridor but a swirling sea of invisible currents, magnetic waves, and scars left by long-dead stars. And Voyager, our tiny and fragile probe, is like a lone sailboat navigating weather patterns we never even knew existed. Its instruments began to paint a picture no telescope could capture. The magnetometer picked up evidence of a sharp misalignment in the galactic magnetic field, where it twisted violently against the field generated by our sun. The clash resembled tectonic plates grinding against each other, not chaotic, but patterned. This turbulence suggested something extraordinary, that our galaxy might possess a magnetic skeleton, vast invisible filaments of force that shaped the movement of matter, radiation, and cosmic rays. Voyager crossed one of these thresholds where high-energy particles suddenly surged, accelerated by distant black holes and supernovae. The transition was abrupt, not gradual. It was like stepping off a beach and finding yourself on the edge of a cliff. For decades, we thought the boundary of the heliosphere faded softly into space. Voyager proved otherwise. The edge is sharp, and once you cross it, the rules of space begin to change. By late 2023, it seemed Voyager's mission had ended. Its signals grew garbled. The data unreadable. The spacecraft's aging systems, designed in the 1970s, looked to be failing. Yet NASA engineers refused to give up. They traced the failure to a single corrupted memory chip, possibly struck by a cosmic ray, the very kind of particle Voyager was out there studying. From 15 billion miles away, they performed what can only be described as surgery across time. They rerouted Voyager's software into unused backup memory, reviving a machine older than most of the people working on it. Commands took 22 hours to travel one way. Yet the effort worked. By April 2024, Voyager was alive again. One by one, Its instruments were reactivated, first engineering data, then the magnetometer, then the plasma and cosmic ray detectors. And with each revival, Voyager gave us something no telescope or simulation ever could: first-hand measurements from the space between the stars. The spacecraft had not just been restored. It had been reborn. What it sends now is more than data points. It is a living map of interstellar space. Scientists are beginning to use this information like the beginnings of a galactic GPS, not for planets or asteroids, but for radiation zones, magnetic boundaries, and invisible fog-like clouds. Voyager has already passed through at least 2 interstellar cloudlets, regions of denser plasma and gas, each with unique properties, different pressures, different magnetic alignments, different climates. These discoveries suggest that interstellar space is divided into invisible territories, almost like continents with their own borders. One day, these maps may serve as guides for human explorers venturing beyond the solar system. Just as sailors once charted the trade winds and currents of Earth's oceans, astronauts may use natural magnetic corridors to shield themselves from radiation while traveling between the stars. But there is a deeper implication. The way these invisible structures channel matter may reveal how stars themselves are born. The filaments and shock zones Voyager detects could be the very blueprints for stellar nurseries scattered throughout the galaxy. Voyager's findings are rewriting how we imagine the interstellar medium. Instead of a uniform fog of particles, it appears more like an atmosphere with layers, storms, and pressure fronts. Scientists now describe it as interstellar weather. Voyager's plasma wave instruments detect sudden swings in density, as though the spacecraft is gliding through invisible mists. Some regions are quiet, others vibrate with low-frequency hums like distant thunder. These aren't random. They're structured, layered, and persistent. In earthly terms, it would be like discovering that deserts have currents and tides. The spacecraft is also helping map a much larger structure, the local bubble. This enormous cavity in space, hundreds of light-years across, was likely carved by multiple supernova explosions over millions of years. Voyager readings suggest it is now tracing the bubble's edges, where density and magnetic patterns warp suddenly, almost like ripples around a scar. These scars are not abstract. They are the remnants of violent stellar deaths, the bones of the galaxy etched into plasma and dust. Voyager is moving through this stellar graveyard, decoding its history piece by piece. One of the eeriest revelations is that silence does not exist out there. Voyager hears space. Its sensors pick up a constant background hum, an oscillation that shifts as it moves. This isn't the cosmic microwave background, nor is it just static. Some researchers describe it as the resonance of the galaxy itself, a kind of vibration running through interstellar plasma. It could be turbulence. It could be natural resonance. But no one knows for sure. Voyager is not just detecting the hum, it is traveling through it, becoming part of the song. Each reading transforms our view of space. No longer a flat star map, but a living landscape. The variations in radiation, density, and magnetic fields are not random spikes, but landmarks. Voyager is sketching the first topography of interstellar space: ridges of radiation, valleys of calm, walls of compressed matter. This is frontier cartography on the grandest scale, and Voyager is the scout. Perhaps the most profound lesson is what all of this means for us. Voyager 1 was never meant to discover alien civilizations or to colonize planets. It was built to wander and listen. It was humanity's quiet whisper into the dark. Yet what it's uncovering now is not science fiction, but something even more powerful: the truth that space is not empty. It is alive with history, with structure, with memory. The heliosphere that once sheltered us is not just a protective bubble. It is a fragile cradle. Beyond it lies an ocean of forces shaped by explosions older than our species, currents of energy that will flow long after we are gone. Voyager's findings remind us that our place in the universe is delicate. We have always lived inside a fragile oasis surrounded by a galaxy far more dynamic, violent, and complex than we imagined. Every hum Voyager records, every shift it detects, every hidden structure it traces, together they tell us something simple and profound. We were never meant to stop at the edge of our solar system. The true story of space begins beyond it. Voyager, with its faint golden record and its failing instruments, is writing the first chapter of that story. And even now, more than 4 decades after launch, it is still listening. So the next time you look at the night sky, remember this: 15 billion miles away, a spacecraft no bigger than a car drifts in silence, carrying the voice of Earth and the questions of a species that refuses to stop asking. Voyager is not just out there for science. It is out there for all of us, reminding us that the universe is not empty. It is waiting to be understood.